Hello everyone, welcome to session 4 of the 4G end-to-end signaling course. This session is a direct continuation of session number 3, where we cover the LTE end-to-end network architectures and nodes function and interfaces between the nodes and also the protocols used within the interface. And also we went through the part related to the visualization and cloud, and we explained how the EPC or 4G core network is being deployed within the cloud. So in today's video, we are going to cover the last 3 parts here, which are related to RRC state and what kind of RRC transition state we have, for example, from 4G to 5G and 5G to 4G. Also, we will just go very quick through the transition state from 4G to 3G and from 4G to 2G and vice versa. Then we'll cover the ECM and EMM, which is telling you what is the current core network state as well. Then we'll show a mapping between these both states, which is one from the core side and the other one, which is RRC from the RAN side. And actually this will answer a question where it's saying how the UE is seen in both the radio side and core side. And actually in overall, it's very important to understand this stage as well, because at the very end, you need to know how the network behaves whenever the user is in idle mode and connected mode. For example, we know that idle mode, the user will have paging in idle mode. So this is one example. So we'll go through them, most of the situation we have in RRC Idle and RRC Connected. And session number 4, after this one, we'll start directly with the end-to-end deep dive or signaling procedures, where we'll be starting with the first thing, which is related to the attach, then the afterwards will be tracking area, and so on and so forth. So now let's move forward to see what we have today. So as mentioned in the previous slide, the first part we are going to cover is RRC states or radio resource control states, where the RRC tells us whether the UE is only camped or has active radio resources. In simple words, that means that RRC in idle state or connected state. This is the main job, one of the main job of the RRC state in general. So now let's see what is the RRC Idle, RRC Connected, and what is the main transition idea or states whenever you move from 5G to 4G and the opposite way around. So this is a slide covering the part related to the transitions between 4G and 5G. For example, what kind of RRC state we have in both 4G and 5G and how they move or move between each other. For example, if I would like to move from 4G to 5G or from 5G to 5G. So before going through this figure on the right side, I would like just to explain that RRC Idle in general. In RRC Idle, the user can do camping, cell selection, series selection, as we know, paging as well, right? Paging during the DRX state as well. And also in the connected mode, the user can do the mobility control through the handover, right? And he can do he can send or receive data. So this is the main difference between idle and connected mode. So now for this part, so what kind of transition we have? For example, in case if you are going to discuss the signaling related to the IRAT handover or redirection or whatever, so this is like kind of indirectly related. So for example, as in point number 1, if the users are already in LTE connected mode and he would like to move to the 5G, so in this case, he must do handover. So the handover can be different types. It can be IRAT handover or the redirection. This is another types of, you can say, from handover in an indirect way, but it happens in general in connected mode. So in connected mode, the user perform handover, right, from LTE to 5G. This is the main idea here. And if you check for point number 2, this is in case if the user in idle mode and he, for example, have received SIP 24, which usually used to provide the reselection parameters in order to move to the 5G. So in this case, the user will do a series selection from 4G to 5G. And in the SIP in the 5G, usually the SIP 5 have all the information related to the series selection from 5G to 4G. So this was the main idea about the connected mode and idle mode. So speaking about point number 3, this is actually related to the RRC in active state, which is a new state introduced in 4G. It was not there before actually. As you see in this comment, the legacy LTE till release 8 didn't support the RRC in active. It was introduced in release 15. And this RRC inactive in general is used just to try to save some of the call setup time. So just the user stay in the inactive state so he can do a direct or a quick transition towards the connected mode. So for example, before going directly from connected within the 4G to the idle, he can move first to the inactive state. So in case if he came again or he have any session, he can again move back directly to the connected mode instead in case of releasing the complete context. This is the main idea of the RRC inactive. And for sure 5G RRC inactive, this came directly with the 5G. So this is the main idea. And moving for sure from RRC connected to idle, we already discussed this in the previous sessions. This is like just you do that as I told you, the RRC setup procedures, which is starting from sending user sending RRC connection request. Then the E node B will be sending RRC connection setup. Then the user will be replying with RRC connection setup complete. And the same scenario exactly here. And in case if the user does not have any connection or any from data, it can do RRC release directly from connected to idle mode. This is in the scenarios where, for example, we don't have this inactive state. So this was kind of a quick overview about the RRC connection transition from 4G to 5G. Now let's move from 4G to 2G and 3G. So this slide actually it's exactly the same idea about the RRC control states. Again, we have in 4G connected and idle, the part in the middle here, right? So we have the connected and the idle, and as we mentioned, the idle mode, usually the user read the system information, perform cell reselection, right, and cell selection, and also do listen for the paging or listens for the paging using the DRX, right? Also in RRC idle, this is in case the paging, if you have a paging, this paging can be used for three things, either to indicate there is an incoming call, or there is a system information change, or there is a warning message. While in the RRC connected state, as we also explained in the previous slide, this is the user just in connected mode can now send and receive data with the network. And also during the mobility control, the user can do now handover or mobility through handover. And usually the user will do a measurement in the connected mode and send a measurement report to the E node B, and the E node B based on the measurement report will decide what is the target cell and will start doing the handover. While the RRC idle, while moves from RRC idle to connected, this is through RRC connection establishment, as I mentioned. Again, RRC connection setup request, RRC connection setup, then you receive RRC connection complete. So the main idea of this slide, just to see that in the comparison between the 4G, 3G, and 2G, you see in the 3G, we used to have many different states, right? While in 4G, it's almost two, where we have an additional one introduced in release 15, as I mentioned in the previous slide, which is RRC inactive. So the 4G in general is very simple when you are talking about the RRC connection state, because we have almost only two states, right? That's why I'm saying here the main message of this slide is saying that LTE has a fewer states than UMTS, but still support mobility with UMTS and GSM during using a mechanism depending on whether you is an active or idle. So for example, if the user is in connected mode, he will do an handover, but he will move from the RRC connected in 4G to cell DCH and UMTS. And while he's moving to GSM, he will move to GSM connected or to the GPRS packet transfer mode. This is during the connected mode. While during moving in idle state, for example, he will be using something called CCO with optional NACC. This is just something controlling when and how the user will be moving from 4G to 2G. For example, CCO mean go to 2G now, and this is just meaning cell change order. While the NCC, this is kind of a methodology which is being used by the network to assist the cell change, and this is just used to help or make the change faster and smoother from 4G towards the 2G. So we don't really need to know all this information about the state transition from LTE to UMTS and 2G. Yeah, from high level perspective, but since we are focusing more on 4G and 5G, so most of the network or many of the network now doesn't have 2G and 3G. But just for your information, this was the main states between or transition or interaction between 4G and 3G and 2G. So now let's move to the next slide to see what we have. In this part, we're going to discuss about the mobility and connection management states, which is mainly from the core side. Actually, the core side also tracks whether the UE is reachable, registered, and connected. And this is through the so-called EMM and the ECM states, where EMM stands for EPS management, while the ECM is EPS Connection Management. So let's see now what is the ECM states, what is the EMM states, and how they relate to the RRC. So as you can see in this slide, it's explaining the two parts related to the EMM, which is again stands for EPS Mobility Management States, and ECM stands for EPS Connection Management. So the first part related to the EMM states, this is actually are the NAS mobility states maintained in the UE and MME. So this kind of NAS messages and its NAS state maintained within the UE and MME. For example, here, in case you have something called EMM deregistered, this is EMM deregistered as mentioned here. This means the UE is not known to the MME. This means the user is not yet attached to the network, so the MME doesn't know any information about this UE. Accordingly, the user cannot be paged. If you have any information, the user cannot be paged, and there is no any user plane errors or information. While if the user moved to from EMM deregistered to registered through doing, for example, attach or tracking area update as mentioned here. So what will happen in this case? In this case, the user will be registered in the network and the MME already know the location, at least in terms of tracking area list or tracking area code. And in this case, the user already have active the PDN default bearer. The default bearer is already active and the UE location already known by the MME. So the MME can do paging and can send whenever the user receive any data as a terminating. For example, terminating calls, receiving the data. So indirectly the MME can send the paging towards this particular user. And the main idea that for the moving back from EMM registered to deregistered, this can be done through either detach, normal detach, for example, the user switched off his device or any problem in the network, or PDN deactivation, or tracking area, for example, being rejected. So again, this state, which is the mobility management state, mainly define the UE reachability and service availability. Reachability again means whether the user we know the MME or the network or network know the location of the user or not, in case if they want to reach to the user to do paging and get him back to the connected mode. And just a quick note, that we have additional states for the mobility management, but they are not really important to know. But I just added in the next slide I quoted from 3GPP just to have the complete figure and information. And one important point that the EMM registered, this is not necessarily the user is connected. He can still be in idle mode. For example, he did the attach, but he's still in the idle mode after the attach. That's why we added this comment. So the second part, it's about the ECM or EPS Connection Management. So as you can see, the first one was about the mobility. This one is about the connection itself. So as mentioned here, the ECM states are the NAS connection states between the UE and EPC and MME. So this is a connection state. What is kind of the connection state? Whether the user is on idle or connected. And there are two views. One view from the UE side and the other view from the MME side. So in general, this EPS connection management, this define the signaling connectivity between the and the network. So let's see what we have, for example, in the view here. For example, here ECM idle. This means the user already in RRC idle state. So if he did RRC connection established, so he will be directly moving to the ECM connected, right? And the same if he moved to back to the idle, so he be already RRC connection released. So this is from the UE perspective. From the MME view, this is depend on whether there is a S1 connection or not, which is you will see it in the signaling later on during the attach and even the S1 establishment. You will see this one. So for example, if already the S1 connection is being established, this means already the user in ECM connected as well. And if the S1 connection is being released, meaning that the user already in the idle mode. So what are the main differences in general between ECM idle and the ECM connected? You can see ECM idle, this means there is no NAS signaling connection, means there is no S1 connection to the MME. So in this case, the mobility will be done through the reselection and reselection because the user is considered in idle mode. However, the location of the user is known to the network. They know the location by the TE and T list. and the typical procedures which usually happen in this state, which is a RRC idle states, can be either tracking area update or paging, for example, response, and after getting the paging, he might send a service request. While the ECM connected state, and the main difference is that now the NAS signaling, which is S1 connection, is being established, and the location of the user is known by the A node B. The core network know the location by the A node B because already the user is being connected. That's why it's mentioned here. MME knows the U location at the serving A node B level. And for sure, the mobility will be done through the handover because the user is already in connected mode. And initial NAS messages include attach, tracking area, service request, and either detach. So this was the overall view or understanding about the EMM and ECM. The next slide, I will just show you a direct mapping between the RRC states and the ECM and the EMM states, just to know at what states. It's very easy. For example, at RRC Idle or RRC Connected or EMM deregistered, how the user view and network view will be about this particular user. So I will show you the mapping in the next slide. So just quickly before going to the mapping part, just showing the complete 3GPP EMM states, which is the EPS Mobility Management. I mentioned to you that there are mainly two states, which is the EMM deregistered and registered, and that's true. These are the main states. However, there is something called like initial transition states. For example, here, this is called EMM registered initiated. For example, here, whenever the attach request is being sent, the user is not yet in the EMM registered because in this case, still the attach is not yet accepted. So if the attach is accepted, then the user will be considered as EMM registered. While if the attach is rejected, this means the user is EMM deregistered. So this is kind of an intermediate step between the EMM deregistered and registered. Just, it's not very important, but just I added to have the complete figure about the EMM states as well. So this is an example of the mapping between the three states, which is RRC, ECM, and EMM, just to have a practical or an example which can make it easy for you to understand. For example, assuming that this situation, the user already is powered on, but not yet attached to the network. So just power on. So this means the user is already in RRC idle and the ECM is idle, while the EMM is deregistered. So there is no paging can be done because the network doesn't know the user location, right? So no EPS registration, maybe he's looking for a cell now. While if attached and currently idle, this means RRC is still idle. He already did the attach is completed. So RRC is idle. This also will be idle because this almost matching with the RRC. While the EMM now will be registered. So this means the user is registered in the LTE network and they know the location by the user, or the MME knows the location of the user by the tracking area. So the paging can be done in this case, but there is no active connection. The last part, assuming that now there is an active service and active connection. So this means the user is already RRC connected and the ECM will be connected, and now the EMM as well will be registered. So both there is a connection which is from radio bearer from the RAN side, and also the S1 connection being established between the A node B and the MME. So this was a direct mapping between the RRC and ECM and EMM state. This is the last part of the session 4, and actually it's also the key takeaways from session 3 and 4. Now we're almost done with the 4G foundation, and we'll be moving now to the actual signaling connection and the detailed signaling, where also we've done a few parts of the signaling already during the RRC and RACH procedure and so on, and also during the cell access. So as overall summary from this session, we explained already the LTE architectures, right? Where we explained who's the main actors and what each node do, right? Also, we explained about the interfaces and protocols and what is the main job for all of them. Also, we explained about the RRC states, where we explained what is the radio side relationship between the UE and A node B, where we mentioned there is two states, RRC idle and RRC connected, right? And also we had a view through the ECM and EMM states as well, where this mainly from the core side, which is defining the connection and the mobility state, whether the user is being registered or not. If not registered, meaning the EMM is deregistered, the user cannot do any paging. If registered, meaning the paging can be done. And in case if ECM connected, this means the user is already in connected mode, RRC connected. So there can be done handover and the user is already known by his A node B location, right? And then we went through the mapping between the RRC, ECM, and EMM. And also there is one additional point I did added here, which was about the cloud, where we covered within session 3, where we went through how the EPC or the core network for the 4G can looks like in the cloud or in the visualization. So that's all about session 3 and 4. Now it's being completed. Now we are going to move to more interested part about the end-to-end signaling, where in session 5 we'll be starting with the attach signaling flow, where we'll be describing when the attach is being triggered, why attach is being triggered, how it's being triggered. Then we'll go through the end-to-end signaling with attach. Also, we'll be covering all or most of the messages content as we used to do within the previous session as well. So that's it, and thank you very much, and see you in next video. And I hope if you like the content, to press like and to spread the knowledge.